Hey y'all, it's Mr. Boyd and I'm back at it again, and today we're going to be solving trig equations. In order to understand trig equations, let's start with some more basic equations like we've maybe have seen in our previous math classes. Let's start with this one on the left over here. Okay, if you had to solve this, what would you do? You'd probably remember that you could do things like add 5 on both sides, so you get a 27 on the right. On the left, we'd still have 2/3 x, and then you'd probably remember that we can multiply by the reciprocal of that fraction. So 3/2 on both sides, and then we get, let's see, the 2's cancel and the 3's cancel, and we get 81 over 2. We're just going to leave it like that. Okay, so that was like just basic algebra steps. Do the same thing on both sides until you have an answer, which is very different than what we've done so far in this unit, right? It's been a little bit more ambiguous. This one's pretty straightforward. What about on the right? What's different? Well, this one's quadratic. It has something that's x squared and a linear term and then a constant term. So there's a couple ways we can solve these. We can use the quadratic formula. We can complete the square. We can't do it by just like blasting through the question like this. The way I'm going to do it today is factoring, because that's going to be most useful for understanding what's going to come next here in just a second. Okay, so what we need, this is 2x, and I put an x over here. If we multiply those together, we get 2x squared. We do need numbers that multiply to 1, and so I'm going to have to pick some numbers in here that satisfy that. So let's do -1 and +1, and then I always test it. So I have 1x, or 1 times x is x. And then if we redistributed this, that would say 2x times -1, which would be -2x. And it turns out that x minus 2x equals that x right there. Now we haven't really solved this yet. We still need to do that. We can look at this chunk and say, all right, well, that says x minus 1. It needs to be 0. So I guess x would have to be 1. There's a solution. This one also has a solution, and I want to remind you how to find it. Okay, so what we do is we take that little chunk of algebra, that sort of term right there, and we set it equal to 0. We're going to subtract 1 and divide by 2, so x equals -1/2. Okay, so if you know the unit circle and you're capable of doing this, you're probably going to do pretty darn well in this video today, because it's all the same stuff we've been practicing. We're just now using our algebra skills for solving in conjunction with our learning about trigonometry and the unit circle. All right, now let's look at what are essentially the same questions. They just have trig in them. I actually think the one on the right here is going to be a little bit easier. So take a minute, write that down. Let's compare that to what we just did. What we had a moment ago, we had 2x squared minus x minus 1. Now we have 2 cosine squared minus cosine minus 1. So I hope you can see how that's the same format. And the reason that I've done it this way is that would tell us that it will factor in the exact same way. So that's why we want to understand these more basic ones first. So up here we had 2x plus 1 and x minus 1, which means this is going to be 2 cosine, excuse me, not squared, 2 cosine on the left. And I'm going to do this in the exact same order that we did just a minute ago. And then on the right, we're going to have a cosine, and we're going to have a 1, and we're going to have a 1. One of them needs to be a minus, one of them needs to be a plus. This one was minus a minute ago, and that one was plus. So that's the exact same factoring form. Now, there is a difference. We still, yes, have to solve these, but then we're just not quite done yet. So when we solve this one by adding 1 on both sides, we get cosine theta equals 1. And on the left, we get cosine theta equals -1/2. Now, guys, notice, that's the exact same answers we had just a second ago, right? We had 1 right here, and we had -1/2 right there. But we're not done yet, though, because these equations haven't been solved yet. So what we have to do, we have to take a look at the unit circle, and we have to try to figure out where in the unit circle do we achieve these values. Well, where is cosine 1? That's an x value of 1. That's right here. So that's at 0, both 0 degrees and 0 radians. You should know by now that we're going to be doing it in terms of radians. All right, I'm just going to redo my theta here because that was just a bit too ugly. Then on the left, we want to know where's the cosine value, the x value, -1/2. I believe that's right here at 2 pi over 3, and down here at 4 pi over 3. And that's it. So we've satisfied both of those equations. So a lot of times when I teach this, people think that looks kind of scary at first, this equation, but recognize it's just a quadratic. It factors like any other quadratic, and so we are able to solve it. Now let's go back to the example on the left over here. And it's not the exact same question that we had in the intro, but it's a really similar question. Keep in mind, we want to get theta by itself, so we're going to do algebra moves that are in service of that goal. So let's start out by adding 2 on both sides. So we get 2√2 sine theta equals 2. We want to get rid of this 2√2. Sometimes people get a little sheepish about this. They want to just divide by 2. No, we want the root 2 out of there as well. So let's divide by root 2. Now, I understand the concern that, wait a minute, Mr. Boyden, you've told us over and over we're not allowed to divide by irrational numbers like root 2. You're not supposed to leave them there as a final answer, but you're absolutely allowed to divide by them. So let's see what we have. We have sine theta, and then the 2's here are going to cancel. So I get 1 over root 2, and I say, do I know any places where 1 over root 2 appears on the unit circle? Probably not. Now we're going to do what you probably were already thinking we should, is rationalize this guy. So let's do that. Root 2 on top, root 2 on bottom. So now I get sine theta equals root 2 over 2. And we absolutely know some locations on the unit circle where that exists. So let's go find them. And we're going to have our solution right down here. Root 2 over 2 happens for sine here, and right there, that's pi over 4 and 3 pi over 4. And that's it. One thing I do want to point out, this is a quadratic equation up here. In the past, we learned that quadratics have 2 solutions. This one has 1, 2, 3. That's because the cosine sometimes has 2 solutions. Like this cosine right here had 1, 2 solutions. So yes, it is in a quadratic form, but this is a case because it's composed of things that have multiple solutions, it's allowed to have more than 2. Same thing here. This is a linear equation, but it's a linear equation in trig, and so it can have more than one solution. For some reason, this seems to be a question that a lot of people will struggle with, so I want to make sure we take time to address that in this video. Take a minute and write it down. You may even want to start it on your own and see if you can get it. I'm willing to bet that most of you can look at this and see that, yeah, we're probably going to start by adding 2 and dividing by root 3. So I'm going to do both of those in one step. So cosecant of x equals 2 over root 3. And then what I see a lot of times, I see students do this the hard way. They do things like multiply by root 3 on top and bottom. Now, there's nothing wrong with that. It will absolutely work. You're going to get an answer if you do that. But sometimes it's better to pause in the middle of a question and think, do I know of an easier way? So notice this is cosecant. So you should say, do I know what cosecant is? I do. It's the flipped or the reciprocated version of sine. So if we know what cosecant is, then we actually already know what sine is. So we should know that sine of x is the flipped version of this, root 3 over 2. So you see how now, rather than doing a bunch of extra algebra steps, I actually can look right to the unit circle right now and ask, do I know where the sine value is root 3 over 2? Boom and boom, pi over 3 and 2 pi over 3. Yes, I do. And so that's the quick, easy way to do a question like this. And I also want to illustrate for you, there's no reason to be concerned just because it says cosecant. That's not a problem. Typically, this is what's going to happen. You're going to get to some sort of an equation like this where you'll end up using the reciprocal function to answer the question. Now I want to show you another thing that can happen that can sometimes be a little bit challenging. And I want to remind you of a strategy that I think will be helpful. When you see a trig equation that looks really challenging, try writing out sort of like a sister equation, something that is really similar, but a lot easier, just like we had in the beginning. So if you recall, that's actually how I scaffolded the first part of the lesson. So I was going to start with this example right here with the trig, but I thought, you know what we'll do? We'll do an easier question first. So I wrote sort of like a sister or a companion question that made it really easy to understand what was going on. Let's try to do that here and see what happens. So when I try to do that, I start out with the 2, and I get 2x squared, because the cosine is squared, plus 3, I can't write x, because I've already decided that x represented, or it was a stand-in for cosine. So I need a different variable here, 3y minus 3 equals 0. And the issue is, when we're being asked to solve this, we need to get this down to where we have a number at the end. And I'm not going to be able to do that because this is a single equation with 2 variables. So what that suggests is that I'm going to need a change of variables. Now, here's all you have to do. You notice that the cosine is squared. And if the cosine is squared, we could use a Pythagorean identity. So cosine squared plus sine squared, oops, not theta, I'm using x equals 1. We recall that from previous unit. And I want to isolate cosine squared, so minus sine squared on both sides. And so now I'm going to come over here, and instead of cosine squared, I'm going to write 1 minus sine squared. And I'm going to rewrite everything else. All right, and then I like to put a little box around this. That's kind of my side work. I don't want to get confused. I think that was part of my solution, but that is sort of my thinking on the side to make sure I'm not making mistakes. Now, maybe you can't tell yet if this is better or worse, because it looks worse, but please notice there's no longer a cosine here. Everything here is sine, which means we've gone from functionally speaking, two variables down to one. Okay, let's start simplifying. Let's distribute this in. So I get 2 minus 2 sine squared plus 3 sine minus 3. It looks like we have some like terms that we can combine. I think that says 2 minus 3, so we'll have a minus 1 down here at the end, a negative 2 sine squared here, and a plus 3 sine in the middle, still equal to 0. And then one thing that I notice here is our leading coefficient is negative. Now that is not my personal cup of tea, so what I'm going to do is I'm going to multiply the whole equation by negative 1, and then it's going to look like this. 2 sine squared minus 3 sine x plus 1 equals 0. So the sign on everything changes because everything got multiplied by the same value. All right, so now I've got that positive coefficient. Now I think I'm ready to write out sort of that companion equation. So let's do it. So that would be 2x squared minus 3. Okay, hold on. So we said that x is subbing in for sine. So that's still sine. So hey, I'm good. We solved that issue. Cool. And then plus 1 at the end. Let's try to do the easier question first, then we'll attack the harder question. So let's see. I'm going to need a 2x and an x to solve, or to multiply together to be 2x squared. That's a 1, so these both have to be 1s, and they have to add together to be something negative, so if they're both negative, that would satisfy that. And then I think, all right, if I needed to solve this, how would I do it? I'd get a 1 right here, and then I would, on this side, I would add 1 and divide by 2, so I would get x equals 1/2, and I would get those two solutions. So now that I have that, I can come over and do the exact same process on our trig equation. So this time, though, it would be 2 sine x minus 1 and sine x minus 1. And guys, all I'm doing, I'm just looking right here. Okay, I'm looking at that. I'm just writing the same format for my question. I did the companion equation. Now I'm doing my equation. And we've already shown that by solving it, you're going to get a 1/2 out of this. Notice the same thing's going to happen here. But this time, it's sine x equals 1/2. And right here, you'll be adding 1, so it'll say sine of x equals 1. And with that, it's unit circle time. So let's see where those are on the unit circle. All right. So let's see, sine of 1/2, that looks like here and here, and sine being 1, that looks like it's right here. Let's name those values. That's pi over 6, 5 pi over 6, and looks like pi over 2. And let me rewrite the first one. It almost looks like it's a 7 pi for some reason. So let's do a quick redo there. So pi, there we go, that's better. And then variable is x, so x equals, toss commas in the middle, and we are done. Hope you enjoyed the video, and we'll see you next time.